For millions of years, an intense force has been racing through the cosmos, traveling at nearly the speed of light. Normally, galaxies are separated by vast distances, often millions of light years apart. However, gravity can act as a cosmic glue, pulling clusters of hundreds or even thousands of galaxies into close proximity. When these galaxy clusters drift too near each other, gravitational forces can pull them tighter and tighter until they become inseparable. This gravitational compression, unable to escape the cosmic grip, can lead to colossal and cataclysmic collisions. Recently, scientists stumbled upon one such collision while exploring the depths of the universe. Curious to know more? Let's dive into this fascinating discovery of a powerful force that has been roaming the cosmos for millions of years. Our solar system resides within the Milky Way galaxy, which appears to us as a hazy strip of light cutting across the night sky. This strip, easily visible on clear nights far from city lights, is just a glimpse of the vast structure we inhabit. The Milky Way is a member of the Virgo supercluster, which is further nested within the enormous Laniakea supercluster, a massive structure stretching hundreds of millions of light years across. Astronomers estimate that the Milky Way is accompanied by countless other galaxies, making up an extraordinary system that likely contains between 100 and 400 billion stars, along with an equal number of planets or more. Our solar system is situated about 27,000 light years away from the galactic center, nestled on the inner edge of the Orion Arm, a spiral arm of the Milky Way. This position provides a stable vantage point from which to observe the galaxy, and at its center sits Sagittarius A, a supermassive black hole with a mass approximately 4.1 million times that of our Sun. Around this core, stars and other objects orbit at an astonishing speed of roughly 220 km/s. This rapid motion defies the rules of Keplerian dynamics, suggesting to scientists that an unseen entity, dark matter, exists. Dark matter neither emits nor absorbs electromagnetic radiation, making it invisible but influential, binding galaxies and clusters through its gravitational effects. Seen from other galaxies, the Milky Way is calculated to be moving at an impressive speed of 600 km/s. Further research has revealed that some of the oldest stars in the Milky Way are nearly as ancient as the universe itself, suggesting they formed shortly after the Big Bang, an event estimated to have occurred around 13.8 billion years ago. The Milky Way, along with the Andromeda Galaxy, is one of the two largest galaxies in the local group. Its mass is thought to be between 540 billion and 890 billion times that of the Sun, a range that reflects our incomplete understanding of its full extent and structure. In recent years, advanced technology has provided astronomers with unprecedented views of the Milky Way, revealing phenomena including billions of stars, planets, white dwarfs, neutron stars, and stellar black holes. The interstellar medium, a vast disk of gas and dust, spans the space between stars, serving as the building blocks for new star systems. However, not all notable events occur within the bounds of the Milky Way. The universe beyond our galaxy is a theater of grand cosmic events as well. One of the most dramatic discoveries scientists have made recently took place roughly 730 million light years away from Earth, where they detected a massive shockwave resulting from a colossal cosmic collision. Astronomers have long been fascinated by spectacular explosions and collisions, constantly seeking out ever larger and brighter examples. But few phenomena are as awe-inspiring as the collision of two of the largest objects in the universe galaxy clusters. In February 2022, the Journal of Astronomy and Astrophysics published a groundbreaking study that showcased one of the most detailed photographs ever taken of a vast shockwave. This phenomenon occurs within the galaxy cluster known as Abell 13667, named after the violent merger of two galaxy groupings. Abell 13667 is a dynamic cosmic hub, home to around 550 galaxies that are slowly merging into a vast cosmic soup. The enormous shockwave observed by astronomers is the result of this collision between two massive galaxy clusters. Despite its immense scale, this cosmic collision remains undetectable by most telescopes. However, it has released an enormous disturbance wave that reverberates through the surrounding space. Scientists describe this shockwave as an immense disruption emanating from both ends of the merging clusters, visible only through specific radio wavelengths. Researchers in South Africa employed the powerful Meerkat radio telescope array to capture the radio relics produced by both sections of this shockwave, uncovering structures more complex than anyone had imagined. Francesco de Gasperini, the lead author of the study and a visiting scientist at the Hamburg Observatory in Germany, explains that the shockwaves act as giant particle accelerators. They accelerate electrons to nearly the speed of light, creating intricate patterns of light filaments that reveal the locations of enormous magnetic field lines and the regions where electrons undergo acceleration. While the shockwave was a recent discovery, its origins reach back nearly 1 billion years to the initial collision of the galaxy clusters that formed Abell 13667. When galaxy clusters of such colossal size collide, an immense amount of energy is released. Researchers consider this event one of the largest energy discharges since the Big Bang itself. During the original collision, a massive stream of electrons was set free, hurtling across space at an astonishing speed of 1,500 km/s. As these electrons passed through magnetic fields, they generated powerful radio waves, which Dr. Gasparin and his team detected using Meerkat. Although these radio waves alone could not fully capture the shockwave's intricacies, the Chandra X-ray Observatory helped by providing complementary data, revealing more details about this extraordinary event. Such discoveries are essential for understanding not only the history and composition of the universe, but also the nature of the forces that govern it. Each galaxy collision and shockwave provides scientists with vital clues about the invisible matter and energy that shape the cosmos on a grand scale. In the case of Abell 13667, we are witnessing an echo from a billion-year-old event, still radiating energy across the universe and revealing the interplay of cosmic forces that drive the evolution of galaxies and clusters on the largest scales imaginable. Upon close examination of the cosmic image, one can detect the central cluster of 550 galaxies at its heart, an awe-inspiring formation that stands out vividly against the surrounding backdrop of space. Encircling this dense cluster are red-hued regions which are not merely incidental but hold significant meaning. These red shades represent shock waves generated during the supercluster's creation, hinting at the colossal and turbulent forces at play during these processes. Such observations not only give us a more detailed look into the dynamics of galaxy clusters, but also lead to a paradigm shift in how scientists approach and understand galaxy cluster mergers. This shift highlights the intricate and multifaceted processes that govern cosmic collisions, where massive celestial bodies interact and shape each other across billions of years. Interestingly, in the study of the cosmos, it is often the absence of something, rather than the presence of unexpected phenomena, that poses the greatest puzzles for scientists. For example, in 1981, astronomers from the University of Michigan embarked on an ambitious project. They sought to calculate the redshifts of multiple galaxies to produce a 3D model of the cosmos. Redshift data allows scientists to measure the distance of objects in the universe, offering a kind of cosmic map. As this image unfolded and the model took shape, the astronomers encountered a startling revelation: a vast, empty region in space approximately 700 million light-years away from Earth. This massive, almost perfectly spherical region spans over 330 million light-years and is largely devoid of galaxies. Initially nicknamed the Great Nothing, this mysterious void eventually became known as the Bootes Void after the constellation Bootes, within which it lies. Further, more extensive mapping of the universe revealed that galaxies tend to cluster along filamentary structures that stretch across the cosmos, leaving behind vast, empty spaces between these clusters. These empty regions, or voids, comprise nearly 80% of the observable universe and vary in size, generally ranging from 30 to 300 million light-years across. The Bootes Void, however, is exceptional. Due to its immense size, it is considered a supervoid, one of the largest known voids in the universe. The existence of such voids in the cosmic landscape is a result of the delicate interplay of cosmic forces during the early stages of the universe's development. In its infancy, the universe was a dense, homogeneous soup of matter, with particles uniformly distributed. However, quantum fluctuations at the smallest scales triggered tiny differences in the matter's distribution, leading to an uneven structure. Over time, these small differences caused certain regions to become denser, increasing their gravitational pull. As a result, denser areas attracted more matter, creating a feedback loop where dense regions grew denser, pulling material away from less dense regions. This process, driven by gravitational forces, led to the formation of denser areas and the vast voids we observe today, a process further amplified by the universe's ongoing expansion. As the cosmos expanded, quantum-level oscillations were stretched across ever larger distances, with smaller clumps of matter gradually condensing into galaxies. At the same time, voids continued to grow, sculpting the cosmic web that fills space today. The interaction between gravitational attraction and the universe's expansion gave rise to the breathtaking landscape of galaxies arranged along filaments, with colossal, empty gaps occupying the spaces between them. This cosmic tapestry of structure and emptiness defines the universe we observe.